Learning of mathematics beyond primary classes for classes 9 to 12 has several different stages involved. Concepts. The first is to understand the core concepts, the logic behind each theorem, each rule, and the formulae. This is the foundation for further detailed learning. With a proper understanding of the basic concepts, one can actually understand the topic. Supported by logic and reasoning, instead of having to just memorize the theorems and formulae. Next stage would be to learn the theorems and basic formulae, and to memorize some of them, actually mug them up. Make no mistake, despite all the talk against mugging up, learning of any topic in mathematics will inevitably require a good number of formulae to be mugged up if you have to solve problems and score in exams. However, if the basic concepts have been well understood, the reasoning and logic behind the theorems can be understood, which helps them to be easily memorized and easily recalled when needed. Next would come basic problem solving. This has to go more or less along with learning and memorizing of theorems and formulae. You will need to work out sample problems or exercises which help you understand how and where to apply the theorems. These give you a real and practical understanding of the theorems and formulae, and also help in firming up the memorized things. Advanced problem solving. Most of the competition level questions often involve some tricks over and above the concepts, formulae, and basic knowledge. These can only be learnt and mastered by practicing the problem solving oneself. Merely reading through a solved question paper will not do. One needs to sit with the problem without looking at the solution in advance. There is actually no end to amount of practice required for maths problem solving. One needs to figure out the tricks and learn to recognize the common patterns by working on more and more problems. Though I have never succeeded in solving a Rubik cube, but I believe the thrill in learning to solve complicated problems must be comparable to that. If you have spent some time trying to solve a problem and have been unsuccessful at that, take a look at the solution provided if available. Try to figure out what pattern in the question had the clue to the route taken in the solution. What was the hidden property or theorem that you had not thought of but was required to solve the problem? For a problem that you have solved, be aware, often there are multiple different methods to approach the same problem. In some cases, the situation or the numbers given are such that some particular approach may work out to be much shorter and faster than others. Try to look at different approaches to solve the same problem. Try to figure out why a particular method is better suited to solve this one. What patterns or hints does the problem contain to indicate which approach will work better? I have often felt that the first stage, that is understanding the concepts, takes the least amount of time and effort. If I am asked to quantify, I would say only about 5 to 10% of total time and effort is required for concepts. But if not mastered thoroughly, it makes the remaining stages much more difficult. In this set of mini lectures, I have attempted to elaborate the basic concepts of some of the topics. As time goes, I intend to keep adding to this list. I would love to hear your feedback and suggestions, if any, on thesushilkg@gmail.com.